So, starting off with the Unit 5 review worksheet, numbers 1 through 5, asking us whether each example is convenient, systematic, random, or self-selected. Looking at the first one, to find the mean height of all third grade students, we measure the first 5 students who are dropped off in the morning by their parents. What method is that? There's nothing random about it, right? It's not self-selected, they're not choosing. There's no system. This is pure convenience. It's what's easiest. So for number 2, students working on a survey of student attitudes towards college administrators, talks to his roommate and the other people on the floor of his residence hall. It's not random. There's no system to it. They're not choosing to be a part of this. It's not self-selected. This is convenience yet again. Does that make sense to everybody? They're just doing what's easy for them. Number 3, a researcher wants to select 10 people from a population of 100. Researcher has a list of all 100 people. Assign each person a number from 1 to 100. Picks a random number 6 as the starting point. Then selects every 10th person. So essentially doing, because the sampling interval 100 divided by 10 is 10. So if they want 10 people, they can pick every 10th person and get 10 total. So the final sample is 6, 16, 26, 36, 46, 56, 66, 76, 86, 96. What term describes what they just did? 1 or 2 of you. How about the rest of you? The 2 of you that said something were correct, but the rest of you, this is not convenience. It's not self-selected. They're not choosing to be a part of it. They mention random number, but that's not how they're picking all of them. Does that make sense? This is, as the couple of you said, systematic. They had a system for how they were picking people. Every 10th person. Number 4, population of 1,000 people. You want to choose 50 of them. Each person is numbered 1 through 1,000. Generate a list of 50 random numbers. Those are the ones that are in your sample. What is that? That one's random or simple random? You ask your parents and friends to take a survey. Okay, this one, there's some leeway. This one could either be convenience, because you're asking people that you know, or it could be self-selected, because you're asking them if they'd be willing. Any questions about those 4 types? I want you guys now, that should be enough of a reminder for you to be able to do numbers 1A, 1B, and 1C on the practice test. So if you haven't already done those, I'll give you 2 minutes here. 2 minutes to do 1A, 1B, and 1C. If you have questions, raise your hand and ask. we ready to go over those three? Like most of you are done with at least one or at least the first two. Maybe you're on the last one. So let's talk about it then. 1A. Teacher wants to give the principal a good idea of how Math 3 students are performing this year. Collect the work of every 10th student. Give that to the principal. What method is that? Is not here today. Alyssa, what do you think? Systematic. Every 10th person, that's your system. 1B, student runs for class president, puts up posters around campus asking students to text the school issue that's the most important to them to a specific number. What is that? Jaime, what do you think? A little louder. D for random. So there, in order for it to be random, there has to be an actual tool that's making the randomness. It's got to be a random number generator or a list of random numbers. This one's asking people to volunteer to do it. They have to put in their answer and send it from their phone. So yeah, it's going to be C, self-selected. That's exactly right. Letter C then, manager of a fast food restaurant suddenly remembers they were supposed to be finding out which menu item is most popular. Quickly write down the next 20 things that are ordered. Not here today. Ethan Rocco, what do you think? A, convenience. That's exactly right. It was easy for them. So let's go ahead back. Any questions there for those three? Yes. So for this one, the last one. So the reason it's not a random sample is because while it's going to be kind of random what gets ordered next, in order for it to truly be a random sample, you have to have some way of generating the randomness. Because right now, those 20 people, they could all be from the same party. You've got a youth group that comes in. They're all, next 20 people are all together. Because they're all right next to each other, that's very likely to be biased for some reason. Again, whether it's the time of day, it's the group that just came in, it's people being influenced by what else other people are ordering. There has to be a tool that makes the randomness for it to be simple random. There's got to be a random number generator, list of random numbers, a dice that's being rolled, cards that are being drawn, something to make it random. Does that make sense? All right, so let's go back then to the review worksheet, and let's look at numbers 6 through 12. 6 through 12 is talking about whether it's a survey, observation, or controlled experiment. Which type of study is it? So for letter C, you want to see how much water dogs drink on average per day. What do you think? What would be best for this one? Observation. You watch the dogs, you measure how much they drink during the day. That's how you get your data. So observation. Next one, the principal wants to know exactly how many students have internet access at their homes. What do you think? Be kind of creepy if the principal was just going around watching everybody's houses. So probably not observation. Probably a survey, right? You want to ask them. You send this survey back. Hey, do you have internet access, reliable internet access to your house? So this is going to be survey. Next one, class of 2016 is trying to decide which of the 3 different gifts they're going to present to the school. How would you decide that? Survey again, right? Send out a survey, ask, hey, which one should we do? Number 9, city wants to see the effect of lawns being watered 1 day a week in the summer months compared to being allowed to water 2 days a week. Controlled experiment, right? You watch, okay, what happens to the lawns if they're watered twice a week? What happens if the lawns are watered only once a week? That would be a controlled experiment. Would be best. And that's probably enough for us to be able to answer numbers 2A and 2B on the practice test. I just realized in the last class that when I made 2, I didn't change it to 2B. So make that a 2B right there. And again, like 1 minute to do 2A and 2B. That's fine, as long as you know that. All right, so real fast here. An astronomer wants to determine if there's life on other planets. Are they going to do a survey, controlled experiment, or observational study? Alejandro, what do you think? Observational study. Again, can't do an experiment to find out if there's life on other planets for most people. If you're an astronomer, actually, for just about anybody, you're not going to like do a controlled experiment for that. It's going to be observation, seeing what's there already. And then for 2B, Mark, what do you think? A food scientist wants to find out which artificial sweetener is the sweetest. I'm going to preface this with there is some ambiguity on this one. There's a couple things that you could do. What do you think, Mark? B, controlled experiment. The way the question is phrased, I think that is the best answer. Does that make sense? If it just said which one people liked, survey would be fine. If it was which one do you think is the sweetest, that could be observation. But if you really wanted to like objectively figure out which one per like amount per gram or whatever measurement unit you're using is the sweetest, you're probably going to want to do a controlled experiment. Does that make sense? Set it up, this amount of sweetener and whatever is being tasted, and then have the people try each one and see which one they think is the sweetest. So controlled experimental study is going to be best for that one. Number 3, this one we're just going to talk about real quick. Each year, a business owner surveys their employees to find out how the morale of the company is doing. What would be the best way to conduct a survey? Again, it says best way. Take 1 minute, look through these 4, talk with the people next to you. Which one do you think is best? I'm going to have somebody say what they think is best, and then I'm going to call on some other people and say why the other ones are not the best. Does that make sense? So 1 minute, talk with the people next to you. All right, so let's talk about this one. Which one do we think is best? There is a little ambiguity on this one, but I think there is one answer that is best. So what do we think? For number 3, Alyssa, what do you think was the best one for number 3? So anybody put something different besides D? What did you put, Mark? So I would say probably those are 2 of the best answers. So let's talk about the other 2 first. Why don't we put A and C? Ask the first 20 employees in the front door of the office that morning. Anybody want to say why A is probably not the best? Or should I call on someone? All right. Leanne, what do you think?
I think it's too random and it doesn't really apply to like everyone.
Right, it's that second part. It's not the right kind of random. Does that make sense? Like, we want random. We want to get a little sprinkling of everybody that's in the company. And the first 20 people in the door, that's not really that random. You might have the people that are like, I'm ready for work, I'm ready to go, I'm here early, I love this job, I want to keep going. Or it could be, oh, it's the morning shift. Nobody wants to be here in the morning, but they have to be. So you could end up with like the same kinds of people showing up in the morning all together. Not a good sample of the whole company. Does that make sense to everybody? So I'd say A is definitely not it. What about C? Emily G, what do you think? What's wrong with C? We're just walking around the office, finding 20 people, asking them how they're doing.
That one's more convenience for them.
It is.
So it wouldn't be very fair.
Right. It's convenience. Convenience is usually a bad idea. In this case, the idea is that the people that you're going to randomly encounter are going to, A, they have to be in the office at the time you're walking around. B, they might be the people that are just up walking around anyways. They might not be in a meeting. There could be a variety of reasons why it's not a good sample of the whole company. So we're down to C and D. Or sorry, B and D. How many of you think B is the best? How many of you think D? Okay, so we're about half and half here. The issue I see with letter D is that it's only the people that respond. You're sending it to everybody, which is great. But there's always a slight problem with self-selected. And it's that the people that care the most are going to respond. Does that make sense? Specifically, you often get the people that are the angriest that respond. Does that make sense? The people that really have a problem with something that's going on, they're the ones that are going to say, hey, no, this is not good. Here are my responses. This is what I'm not okay with, or that I upset about. A question like this where you can describe your answer, you could easily argue that D is best because you're sending it to everybody. Does that make sense? And if you really push to get everybody to turn it in, you make it mandatory, everybody has to answer it, D would be great. Does that make sense? But since it's self-selected, only the people that want to answer do, I'd say that actually B is probably best. You're getting a true random sample, 20 people out of the whole company. As long as you make sure that they all answer, that's probably going to be best. Does that make sense to everybody? All right, so let's keep going. I want you guys to go back to the review worksheet on the next page. Let's actually look at 18 through 22 real fast and remind ourselves of these terms and some of the vocabulary that we used. This symbol right here is the average or mean. Now again, in true statistics, there would be a difference between mu and x bar. We are saying that they are the same. In real statistics, one would be the population mean and one would be the sample mean. Does that make sense? There'd be a difference depending on whether it's just a group or the whole population. But for us, those are both the mean. This symbol right here is standard deviation. This is actually the formula for the mean. You could even just say that this is the mean, but this is how you find it. It's the sum of all the terms divided by the number of terms. This guy right here is the variance. And the variance is this formula. This is the symbol for variance. This is how you find the variance. Does that make sense to everybody? Does anyone have any questions about those vocab terms there? With that in mind then, I want you guys to come down here and answer 25 and 26. The instructions are up on 23, but we're going to do 23 later. Find the standard deviation given the following. Does everybody see this in the variance formula? The sum of x minus mu squared is the top of my variance formula. This right here is from these big tables that we were filling out. See right there at the very end? It's the sum of the differences squared. So they're telling you, I already did the entire table for you. I did all the hard work. Here's the answer at the end of the table. N equals 7. That's the number of terms. So the variance is the sum of the differences squared divided by the number of terms. So right now for 25, variance is 84 divided by 7. So I can do that, 84 divided by 7, get an answer. 84 divided by 7 is 12. But notice that variance is standard deviation squared. So I need to take the square root of that. That would be my very last step. Again, if I'm finding standard deviation from scratch, I'm doing that whole table, getting this number, dividing by the number of numbers, and then taking the square root. So the square root of 12 is about 3.464, or just 3.46. Notice on 26, they've even gone a step farther for us. All you have to do is say, well, square root of that, standard deviation is 4. There is my answer. So now on the practice test, I want you all to turn to the second page and try number 4. Find the standard deviation given the sum of the differences squared and the number of terms. So everybody try number 5. Give you 2 minutes. Shouldn't even take that long. 1 minute. Also, I did get a box of scientific calculators from another teacher. If any of you want a scientific calculator to use, whenever you want to use it, just let me know. I'll give you one in exchange for either your ID or your phone. I will try to have a more organized way of doing this on the day of the test so that everybody can have one. But if you want to practice using a scientific calculator right now, raise your hand and I'll get you one. Just give me either your phone or your ID or something to help you remember to give it back to me. Does that make sense? Does anybody need one?
Oh, no, I was just asking if we could bring our own to use on the test.
You may use your own scientific calculator so long as it's a scientific and not a graphing calculator. Yep. If you have your own scientific calculator, you are welcome to use it on the test. divided by that. If you want standard deviation, you have one more step to do. Everybody, make sure you're reading the instructions all the way through. You're looking for standard deviation here, not variance. Make sure you're getting standard deviation. All 4 of the answers that are up there are easy to get, especially if you make a little mistake. Only one of them is the correct answer. So let's see if we got it. For number 4, which is it? A, B, C, or D? Ethan R., what'd you get? Ethan Rocca. C is correct. Some of you put B. I was noticing lots of B's going around. B is the variance. You must take the square root of variance to get standard deviation. D is if you do things in the wrong order. D, I think you end up getting that if you take the square root of 70 and then divide by 5, instead of dividing by 5 and then taking the square root. Okay. And then A is just half of 70. C is the correct answer there. Now, number 5, draw a box and whisker plot. Let's look over on the homework. Let's look at number 30. Or sorry, not the homework, on the review packet. Look at number 30 down here. Number 30, use the data above to create a 5-number summary. So let's get this just real fast if we can. First off, class, are these numbers in order? You must check that every time. Make sure it's in order. Now let's get the minimum. Bianca, what's the minimum number here?
2.
Perfect. And let's get the maximum. Nate, 41. And then we need the median, the middle number. So the problem is here, 1, 2, 3, 4, 5, 6, 7, 8. There is no middle number. So I'm going to need to combine those two and divide by 2. So again, 21 plus 25 divided by 2. Emily G, what's the median for this one, the average of those two? $23 is correct. Then I have a lower set and an upper set. There is no middle number once again, so I'm going to have to take an average of 18 and 19. Nick, what's that average of 18 and 19 going to be? 18.5, that's going to be our Q1. And then we're going to have to do the same thing here for the upper half. Ethan Bravo, what about you? What's the average there for Q3? 28.5. So we've got our 5-number summary. You could even plot those right now for your box and whisker plot if you wanted to. So I would mean I'm going all the way up to 40. I should probably count by 5s again. 5, 10, 15, 20, 25, 30, 35, 40, 45. So I can put 2 down and put 18.5, be like right here. Should be even maybe a little bit over. 23 would be right here. 28.5. And then 41. And I can make my box right now, but I can't draw the whiskers yet because I haven't checked for outliers. So here's my box. I need the IQR, the width of the box. To find that, I'm going to do Q3 minus Q1. So the IQR, Q3 minus Q1, 28.5 minus 18.5 gets us 10. Turn to the person next to you, check with them, what am I multiplying 10 by now? I'm going to multiply it by a number. What is that number? So class, what am I multiplying by? 1.5. Always by 1.5 here. So 10, that's the IQR. Go ahead and write that down. But now take that 10, multiply by 1.5, and get 15. 15 is what I'm going to add to Q3. So Q3 is 28.5 plus 15. 28.5 plus 15 is 43.5. That's my upper boundary. 43.5. And then my lower boundary is going to be Q1, 18.5, minus 15, which is going to be 3.5. That's my lower boundary. Do I have an outlier? What point is outside the boundaries? 2. Does everybody see that 2 is below the lower boundary? So that's my outlier. What do I do to the 2 on my graph? Cross it out. Make it an X. And then what do I replace it with? The next lowest number. I still have people that are trying to put a point at 3.5. This 3.5 is not a part of my graph. It's a boundary. The only point that's on my graph is the next lowest number, which is 18. So that's like right next to my box. Really short whisker on that side, long whisker on this side. There is my box and whisker plot. Look at letter D. If the outlier was removed from the data set, what would happen to the average, the mean of the data? What do you guys think? What happens to the average if you remove the lowest number here? It's going to go up. And that's going to be our explanation. So, the mean would increase because we removed a number that was lower than the mean. So I'm going to remove a number that was lower than the mean. That's going to make the mean go up. If the outlier is removed from the data set, what would happen to the standard deviation? Right? Is my data getting more spread out or less spread out? Less spread out. That means the mean, the standard deviation is going to get smaller. So you could say that however you want to. The standard deviation would decrease because the data would be less spread out. You can phrase that however you want to. But you should now be able to do number 5 on the practice test. Everybody try number 5 on the practice test. Quick warning with it. On number 5, they don't give you this kind of guidelines. So just make your own number line, some way of making sure that your box and whisker plot is spread out appropriately. Okay? So everybody try number 5, though, on the practice test. specific middle number, you take an average of those two, you add them up and divide by 2. Give you like 3 minutes here, maybe 4 minutes to finish your box and whisker plot if you haven't already. Again, check for outliers, do the whole process. Finish quickly, go ahead and go on, see which other questions you remember how to do. Is anybody done with theirs and willing for us to take a look at it? Anyone willing to show the class what they have for their box and whisker plot? So here's one. So you don't have to list the 5-number summary. It'll all show up on your graph. If you want to, you can. But we've got, again, the mean of 15.5 because there was no middle number. Q1, Q3, 12 and 17. And the minimum is 1, maximum is 20. Notice that we have it nicely spaced out here, counting up by 2, so try to make sure it's evenly spread or appropriately spread. They found the IQR. Let's see if they show it right there. Finding the IQR. 17 minus 12 is 5. Multiplied by that 1.5. 7.5 then is what we're adding or subtracting. So 17 plus 7.5. 24.5 is the upper boundary. 12 minus 7.5 is 4.5. That's the lower boundary. That 1 is our outlier. It gets crossed out. And it gets replaced with the 10 as the bottom of the whisker. So there. 12, 15.5, 17, 20. There's our box and whisker plot with our 1 outlier. Any questions about that one? All right. So thank you. Next, let's take a look. This next piece probably has the most in it that we do. Like, it comes up the most on the test. We've got like 5 problems that all go along with this one. So let's take a look at 33. Everybody turn in the review packet to 33. So for 33, they give us this bell curve. They tell us it's normally distributed. They give us a mean of 5.5 and a standard deviation. That's what we're going to use to label the bottom of this graph. So the mean, 5.5 or 550. Then count up and down by standard deviations. So $6, $6.50, $7, counting down, $5, $4.50, $4. You will have to fill that in every time. It's going to be different every time. The part that's the same every time, but that you still have to fill in, are the percentages. So if I divide this graph up, I am going to give you the empirical formula, 68, 95, 99.7. I will give that to you the day of the test. You need to know how to label this from this. Knowing that, okay, one standard deviation out is 68%, so half of that is 34 and 34. Going out again, half of 95 is 47.5 minus the 34 would be 13.5%. Going out again, you could do 99.7 minus 95. Would be 4.7 divided by 2. Would make this 2.35%. And this 2.35%. And the last pieces, the 0.3% that's left over, cut in half. 0.15%. 0.15%. You need to either straight memorize that or know how to come up with it from these three numbers. Does that make sense to everybody? These numbers don't change, the percentages don't change, but you have to be able to fill them in. So now, once you've got that done, we can go ahead and answer the questions down here. What percent of customers spend between $4.50 and $6? Okay, here's $4.50, here's $6. In between is 13.5% plus 34% plus another 34%. Add it all up and you get, I think it's 81.5%. Does that make sense to everybody? Combining percentages from that chart. That's a little bit different than for F, where it says approximately how many customers spend between $4.50 and $6.50. So $4.50 to $6.50, I still have to find a percentage. 13.5, 34, 34, 13.5. Which equals 95%, because it's essentially two standard deviations above and below. I need to take that 95% and find what number that is out of the total. So 95% is 95 out of 100, should equal some number out of the total number of values, people, samples in the sample, or individual numbers in the sample. So it says there's 150 customers here. That's what goes on the bottom. Then you solve it however you want to. Cross multiplication will work just fine. You can do 95 times 150. Get 100 times x equals 95 times 150 is 14,250. Divide by 100, 142.5 equals x. Can I have half a customer buying lunch though? No. So we're going to say instead that this is just 142. Don't round it, just cut it off. Approximately 142 people. Because that last person didn't make it. What I just showed you there is going to cover most of questions. Let's see, I had written it down earlier. Questions number 6, 12, 15, and 19. All right, 6, 12, 15, and 19. I want you guys to start on number 6 right now. Your homework is to finish these 4 questions tonight. If you can do that, tomorrow we should have no trouble finishing the rest of the review, the rest of the practice test. So this is on the practice test. I want you to do number 6, 12, 15, and 19. If you do more than that, that would be great. You've got about 5 minutes right now, though. See if you can knock out number 6 at least.